In this video, let us look at how we can separate the inks in different colored markers by using chromatography. Using a filter paper, we first draw a start line about 1.5 centimeters from the base using a pencil. Next, we apply small but concentrated spots of our samples on the piece of chromatography paper. This is important to ensure that there is enough sample as the individual components will be diluted when they move along the paper. If the sample spots are too large, it will be difficult to distinguish the individual spots on the chromatogram. The spot is made as small as possible so as to prevent tailing as well as smudging when the inks or dyes are being separated. Chromatography is the technique used to separate small amounts of substances from a mixture based on the different solubilities of the components in a particular solvent. Now pause the video and think about what are some of the advantages of using chromatography over the other separation techniques you have learned. The principal advantage of using chromatography is that only a very small sample is required for the analysis. To begin, we first add a small amount of a suitable solvent to the beaker. In this case, why do you think water is a suitable solvent? The choice of solvent depends on the type of sample we are using. In this case, as we are using water-based inks, water is a suitable solvent because the inks are soluble in water. Moving on, we now place the chromatography paper and immerse it in the solvent. We also must not forget that we have to cover the beaker with a lid. Why do you think this step is important? Covering the beaker with a lid minimizes evaporation of the solvent as it travels up the chromatography paper. You can see that as the solvent moves up the chromatography paper, it carries the different dyes along with it. Dyes which are more soluble in the solvent will migrate faster and further along the chromatography paper. Here we see the solvent front moving upwards. When the solvent front has reached near the top, we then remove the chromatogram and mark the solvent front with a pencil line. Why do you think this step is important? The applied spots will be traveling up the chromatogram relative to the measured solvent front. Knowing the solvent front is important for the calculation of RF values. Notice that I also let the solvent front run as high as possible before removing the paper. The further the solvent front from the start line, we can ensure a better separation for the spot of the dye for accurate identification. However, we cannot let the solvent front overrun, otherwise we cannot measure the actual distance covered. Let us take a look at the results. We find that many of the inks are made up of a mixture of dyes except for the yellow one because there is only one spot. We can say that the yellow ink is pure because it is only made up of one dye. The black ink is a mixture of 3 different dyes, of which the blue dye is the most soluble in the solvent as it has traveled the furthest. The blue ink is a mixture of 2 different dyes, one blue and one purple, and the purple dye is insoluble in water, that's why it remained at the start line and did not migrate up the paper. For the dyes that were not well separated, we can consider changing the solvent. Now let us repeat the experiment, but this time let's take a look what would be the outcome if we had drawn the start line using ink instead of pencil. We can see that the ink, being soluble in the solvent as well, will also move up the chromatogram and complicate the results. Summarizing what we have learned so far, how do you think you will answer these two questions? Let us repeat the experiment again, but this time let's see what happens if the ink spots are below the solvent level. We observe that the different inks do not get carried up the paper, but instead dissolve in the solvent. The inks cannot be separated. It is therefore important to ensure that the sample spots are above the solvent level. This is to prevent the sample from dissolving in the solvent before it is carried up the chromatography paper. This would prevent the separation of the different components of the mixture. Now let us summarize the 3 different experiments we have done in this video, and hopefully you have a better idea of how chromatography is done. Thanks for watching.